Okay, yeah, let's get started then. So hello everyone again, I'm Andrew Rushworth. So I'm a solution engineer, primarily working with the Bugsnag product, which is part of the SmartBear family. So I'm going to be just hosting and introducing today's session. The main interesting part of the session is going to be run by Michael, who's our OpenTelemetry expert, who's come with Aspecto, which is the newest addition to the SmartBear family, which we're very excited to have on board. So yeah, and Michael, if you could just go to the next slide, and what we'll do is just give a quick intro to SmartBear for you, those of you who don't know. So SmartBear is a global company, similar to all of you kind of listening in over the world here. We have customers everywhere, and we have a lot of them. If we go to the next slide, what we particularly focus on is the software development lifecycle. So we're interested in providing you tooling at every stage that you're developing your software, down from designing it through to the testing part, and then to how you observe how your applications that you've built are performing in production. And that's the area we're really going to focus on today, how we can leverage OpenTelemetry in the observability space. So as you can see here, we've got Bugsnag, we've got AlertSite, and we've got this new addition, Aspecto, which really kind of pushes out SmartBear's offering in the OpenTelemetry space. That's enough from me today. I don't have too much to say. I'll be monitoring the chat. I'll try and answer any questions I can. If not, I'll flag Michael to answer them when we get an opportunity. Yeah, enjoy, guys. Michael, over to you.
Thank you. Thank you very much. So, hi, everybody. My name is Michael Haberman. I'm an architect here at SmartBear. And today we're going to learn about OpenTelemetry. We're going to start from the very basics and work our way up. And the main three things that we are going to figure out is to understand OpenTelemetry, why it was created, what is its offering, how it works. Also, we will see a demo on how to actually run it, so you'll have a real experience to really understand how to install it and get started with it. And one of the things that nowadays are very important is cost saving, so we will touch in that a bit. So just before we're starting to kind of explain what is OpenTelemetry, just a bit of history, and this history is basically the grounds and the foundation that allow OpenTelemetry to be born and also to be very trendy as it is today. So there are two main factors that come into play in the monitoring world and the APM, the application performance monitoring world. So most organizations, most companies would use vendors in order to monitor the application. Most of them are proprietary vendors and solutions. Some of them are open source, but in general, you would go to vendors in order to monitor your application. And as developers in general, we like the ability to have flexibility, to use open source, not to be vendor locked. And it is a very vendor locking space. So this is one thing that OpenTelemetry wants to solve. And the second thing, in the past 5 years, we started to see a shift from monolithic approach, having one big application doing everything, to more small application and go with the distributed system approach or microservices approach, where that is a great approach, but with any new technology, it has its downside, and monitoring in this environment usually tend to be complex, and OpenTelemetry tap this area as well. So this is kind of the background to our conversation today. And with that in mind, let's introduce OpenTelemetry. So first thing first, OpenTelemetry is an open source project aimed to allow you to monitor your application. This project is under the CNCF umbrella. CNCF is the Cloud Native Computing Foundation. Basically, it houses many projects that allow us to use them in a cloud-native environment. The most famous one is Kubernetes, but there is a lot other projects that probably you are using in your production environment right now. But the second most active project is actually OpenTelemetry. It gained tons of traction lately. When I say lately, I mean the past 2 years or so. So there is a large community, end user vendors, everybody is contributing to make sure this project will succeed. So this project, at the very core of it, is basically a specification, bunch of README files in a GitHub repo that explains how we want to collect monitoring data in a unified way. All the different monitoring data that we want to collect, we expect OpenTelemetry eventually to allow us to collect it by OpenTelemetry. So the specification tells us how to collect the data, how the data looks like, how to send it from the application to whatever destination it is. But just having a specification is not much. You need to have really an implementation. So on top of the specification, we have implementation in each programming language, not all, but the most common one. I think OpenTelemetry today supports 12 different programming languages. So the famous one like .NET, Java, Go, Node, Python, of course, all of them are supported. So the implementation is basically an SDK that you can import as a library, as a package into your code, and then you can start to collect monitoring data. And there is, of course, another component, kind of a backend component that can ingest this data. And we will go through all of that with more details during this talk. So when I'm saying all monitoring data, we need to kind of explain a bit what it is and what I mean. So as of today, OpenTelemetry supports 3 types of monitoring data, or as we call it in OpenTelemetry, signals. We have 3 types of signals. We have the logs and metrics, which I'm guessing everybody knows because they have been with us for decades. And the new addition in the last few years is traces or distributed traces. So those 3 components or signals are the core of OpenTelemetry, and those are the kind of must-have tools in order to debug application these days. But OpenTelemetry doesn't want to stop there. They want to add more signal as we go, thinking about error and collecting error with OpenTelemetry, code profiling, and more to come. So I'm assuming that everybody knows logs and metrics, but I want to kind of make the argument why traces was created in the first place. Before even I'm showing you what is a trace and how it looks. But first, let's see why we actually needed that. So again, let's put the mindset of we moved from a monolithic application to a distributed application. So now we have multiple services, multiple processes that we need to monitor. So let's talk about metrics and logs separately. I'll start with metrics. So metric is a very important signal that is basically, at the end of the day, it's a number. You have a specific number describing something very specific in your system that if this number exceeds a certain threshold, it probably means that something is wrong in the system. So let's take, for example, the CPU utilization of a service, right? If that's at 100%, something bad is about to happen. If you have an increased rate of HTTP 500 response, that means that something isn't working properly. So metrics are very good to give you an overall health of your system, and they are very specific to a specific component and a specific metric. So then we have kind of the counterpart of metrics, the logs. Logs are somewhat the opposite. They are very down to specific kind of the story of the application, right? We write the code, and within our code, we just add lines that we later on expect to read, and we expect to understand how the system performs, how the system behaves. based on this story that the application wrote up to us. And thinking about monolithic application, you have one application writing the story, and then the story is kind of whole, and you can understand it, and you can just read it line by line. When you're talking about microservices, and definitely when you have a lot of them, then the story is broken down into pieces. So when it's broken down into pieces, now you doesn't necessarily can just read through the log and it would make sense, because you have different portions of the story. So it would be up to you to kind of create this context from all the services and build a story from these logs. So while logs are great, I'm not trying to say logs and metric are not great, they just lack the context, the kind of the distributed context of the correlation of the communication between different services. So this is why tracing was created. And I think this is the time that I'll give you a quick look on what is a trace and how it looks like. So in front of you, you can see a trace. And within this trace, we will be able to see three main things that are happening here. So the first one is this visualization that we can see here. We have some client, an HTTP client in Mozilla, so it's probably a browser. It sent an API call to the order service, and the order service then sent an API call to the authentication service, and then the authentication service communicated with a third party, in this case Auth0, and after that we communicate with the stock service that used the MongoDB database and another database. So if you were to kind of create this map from metric, that probably is not possible. With logs, you would work very, very hard to come up with this map, but with traces, it's actually very, very simple to do. So traces trying to build this map, this context between services. So this is the first portion, just having like an eye-level diagram overview of the communication between the main components. The other portion, this is the timeline. This is where we can actually start to see each individual event, or we should actually call it spans, and I'll explain in a second why we call it span. So here you can see the order services communicate with the authentication service. We already know that. But then it's communicating with the stock service. And the reason that I can say it then communicate with the stock service and not in parallel is because I have here the timeline. And the timeline is telling me two things. It is telling me how long each operation took, or each span took. And also it is telling me whether it's happening in sequence or in parallel. So for this instance, you can see that this is a trace that took 2.1 seconds. And you can see here that we have tons of DB queries that are deleting just one item. Each one of them is pretty fast, but because they are not running in parallel, that's creating a performance impact. And analyzing that from log would be very hard, but seeing that from traces is pretty obvious that we have this staircase pattern that we can just parallel all these DB queries, and that would improve the performance using traces. So this is the kind of the timeline portion, and I want to emphasize two things. So first of all, why it is called a span and not an event. So an event occurs at a particular point in time, and spans is actually starts at a particular point in time, but it has a duration, and that's making it that it spans over time, and this is why we call it spans. The second thing that I want to point out, in a few slides, we will discuss how OpenTelemetry works, how OpenTelemetry can actually construct this beautiful visualization. But first, we need to understand an important thing. You can see each span here has a parent. So we can see here a call to Auth0, and we know that the call to Auth0 happened because the authentication service got an API call to the user verify, and we know that happened because the order service called it. So we know what happened, but also we know why it happened. And this is because we have a parent-child relation between the spans. And keep in mind that we need to know, each span needs to know whether it's the root one or whether it has a parent like this one. So this is how a trace looks like, and this is what you can generally learn from traces. So this is kind of magic, right? If you think on how to implement it yourself, this is a lot of things that you will need to do. And I want to show you a quick diagram that will emphasize how OpenTelemetry is able to do it. So in front of us, you can see that we have two services, service A, service B, and we also have some OpenTelemetry backend. I'm not going to talk about this yet, but we have something that can ingest OpenTelemetry data. And within those services, we implemented the OpenTelemetry SDK. As we said earlier, we have an implementation layer of OpenTelemetry in each language. So if service A is written in Node.js and service B is written in Go, we would implement the appropriate SDK in which one of them. And we know that service A is sending an API call to service B. So we have a communication between them, and let's assume the communication is HTTP based. So those are being sent. So when service A is going to send an API, send an API call to service B, it needs to report a span that's describing what happened. So you can see here we have a span, the API call to service B. So service A is indicating that that's what happened. And we have some random trace ID, and just number 1, and span ID 55, again, just a random one. And since there is no active context, this is just the beginning of the trace, the parent is null. So we know this is the root. We need, when service A is going to say, I got an API call from service B, and I apologize that I have a mistake in the slide. It's got an API call from service A, not service B. So it's going to report, it needs to report that it's part of the same trace. So somehow OpenTelemetry needs to know that this is the same trace. And what OpenTelemetry does is when it's actually going to send the API call to service B, it's going to automatically inject to the HTTP headers the OpenTelemetry context. And the OpenTelemetry context is going to contain the active trace ID and the active span ID. And it's going to write it as a header in the HTTP headers. When service B is going to get the API call, it's going to look for those headers. And then the SDK would say, okay, I see there is an active context. I need to respect that. And it would say, I'm now part of the trace ID 1. I'm sending a new span, so it has its own new ID, 66. And then when I'm reporting who is my parent, I'll take the parent from the HTTP context headers. So I'll use the one that I got, which is 55. And then if we have this data in this structure, we can start to construct a trace from those spans. Two important questions that usually people ask is, does it specific to HTTP? The answer is no. Any network communication that allow you to send metadata, which is most of the communication out there, you can solve that, so you can inject it. So if you're using Kafka, Kafka has attributes. If you're using, I don't know, SQS, you have metadata. So most communication out there are supported. And then the next question is, do I need to inject those headers, or do I need to extract it in the other side? And the answer is no. OpenTelemetry can do it for you, or it does do it for you. So it happens absolutely automatically, and it works out of the box. All right. So if that's clear, and hopefully it's that clear, let's move to talk a bit about code, because that's the kind of the interesting part. So I have here in front of you a very simple project, a demo application, consists of two services. I have here the item service and the user service. And let's shortly review their code. Again, it's a very simple demo. So the item service gets an API call to /data, and it would send an HTTP call to the user service and just respond whatever the user service is responding. Unless we specify within the query string the key fail, then we will throw an exception and return 500. By the way, I didn't say this is Node.js with TypeScript. While this is specific to this language, in general, everything I'll say about Node.js applies to all other languages. So this is the first service. And the second service is the user service. The user service gets an API call to /user, then send an API call to some mock. I'm using mock.io here. And then we are randomizing a number from the array that we got as a response, and we just return one item out of this array. So this is the application. Again, very simple and very straightforward. And now we want to see what was the OpenTelemetry implementation. So as you can see in both services, I have those two lines right here. I'm importing a tracer file and I am initializing it. And same goes for the item service. I am getting the tracer file, initializing here. The item service is also getting something called a meter that we will see in a second what it is and what it does. So basically, this is all you need to do in terms of implementing the new OpenTelemetry menu service. And let's see what we have in the tracer file itself. So the tracer file is a pretty short one. There isn't a lot that needs to be done in order to install it. And what you can see here is that we define here the metric part and define here the traces part. And let's talk about each one of them. So the first portion is defining the metrics. Basically, we want to export data to Prometheus. So Prometheus usually scrapes your application. So you just spin up a Prometheus exporter, and it would spin up an endpoint that Prometheus can scrape the data from. So this is just how you can communicate with Prometheus. And then you create a meter provider. A meter provider, it's basically where you're going to define your metrics. So we are just saying how to send those metrics, at what interval, and the name of the service, so that we would know who is the owner of those metrics. This is all you need to do in order to define the metrics. We will see how we're using the meter in a second. And then to define the traces, same goes to tracers. First, we need to define the exporter where we want to send the data to. I am using here Jaeger exporter. Jaeger is an open source visualization tool that can visualize traces, pretty popular. So that's what I'm using here. Then I'm defining the provider and providing the service name. And I am saying which instrumentations I want to turn on. I've chosen here to enable the HTTP instrumentation, so we will see HTTP calls, and also the Express instrumentation. And if you're not familiar with Express, it's an API RESTful framework that is quite popular in Node.js. OpenTelemetry in Node.js has about 50 instrumentations, so there is a bunch of them. I chose here just to show two. And you don't have necessarily to enable each one. You can just say to OpenTelemetry, hey, turn on everything. So it's up to you how to decide. Basically, once you created this file and imported it in your service, you are good to go. And let's see that actually everything is working. So first, I'll spin up a Docker compose that will run Jaeger and Prometheus because we need those. And then I'll run the item service and I'll run the user service. And once we have both of those running, we can actually go and make sure that everything works. So first I'll send an API call to /data, and you can see here that I got some data. And if I'll do fail equals 1, as you recall, in the code we throw an exception, and we indeed got an error. So let's go back to Jaeger. So this is Jaeger, and within Jaeger, you can see which services you have, and you can see for each service what are the operations that you have. So let's find the relevant ones. So you can see just a few seconds ago, we got the item service, and we have a trace with 6 spans, 3 in the item, 3 in the user service, and we have a trace with errors only in the item service. Let's take a look at those. So right here, you can see the trace. Again, it's a demo trace, so it's not very interesting, but you can see the item service getting an API call, sending an API call, and the user service gets it and then communicates with Moki.io as we expected to see it. So we have all the interesting data here. And then we can take a look at the error one. Again, only the item service, because we threw an exception before we called the user service one. But here we would see one additional interesting thing. So you can see here that we got an error. We can see this is 500, but we also made the extra mile so that you would have the error itself. So you can see the message, a really bad error, and also you can see the stack trace. So you have both the trace itself and the relevant error within it to make it easier for you to debug it. So I would like to show you a few interesting things in the code. That few tweaks that I created to make the thing work. So if you look right here, so in the item service, we are throwing the exception, then we are catching it. And I did 2 interesting things. So when I got the exception, usually the code that you would see is you're going to write a log saying, I got an error and whatever needs to be reported, and then we want to return something to the client. I did 2 additional things here. So while I'm writing the error, I also included the trace ID. So I went to OpenTelemetry, I went to OpenTelemetry API trace, and I asked for the active trace. I got the active trace, and then I asked for the trace ID. And what this is creating is that when you are looking at your logs, and most likely you're used to debug things using logs, so this is probably going to be your go-to tool. But probably in some cases when the error is not that doesn't make sense, or you want to get more context, then what you could do is you go to here to the trace ID, you just grab the relevant trace ID. And this is the trace ID that relates to the error. And you go back to Jaeger and you just throw here the trace ID and you get the relevant trace. So this is a very important integration that you need to create. And it will allow you to have better understanding of the correlation between logs and traces. 2 things to mention here. So I would recommend adding here the span ID as well. So not only you will know which trace is relating to this log, but actually which span within this trace. So it will provide you better accuracy. But also, I can have this cool ability. I can read your mind, and you're saying, hey, I just don't want to go to every log statement in my system and inject this trace ID. It's very hard to do, and you're right. So most likely, OpenTelemetry can do it automatically for you. If you're using a log driver or a log library that OpenTelemetry support, it can do it automatically. The same way it can automatically identify HTTP calls and those kind of things, it can also identify logs and inject the relevant trace ID and span ID on your behalf. So this is one thing that I think it's very important to know and to get familiar with. It creates a very easy transition from log to traces. Another thing that I added, so again, this code is doing something that could be hard to figure out from traces. So I sent an API call to a third-party API. Then I got an array as a response, but then I responded from the service just a single item. So there is some magic that happened here, and we just randomize a number. So whatever developer is going to read this trace, it's going to be pretty hard for them to understand what happened here. So I, again, took the active span and actually added an event. And within this event, I'm going to say, hey, a number was randomized, and this is the index that was randomized. So if I go back to the search and go here, so in our service, you can see that we have a context. So you can see this message and this data that is going to help you to understand the trace, basically kind of leaving breadcrumbs to some other developer that is going to read that. And here, I'm not sure if you can see, there is a little pipe that shows you when this event happened over time. This happened at the very end of the span, but it may happen in the middle, and it would help you to figure out when it happened. So this is another tool that you can add data and extend the basics of OpenTelemetry. So this is for the traces and the logs part. If we also want to talk about metrics a bit. So as you remember, we defined the metric exporter, and we have the metric provider that we are exporting. And if you look at the item service, when we initialize OpenTelemetry, it gives us back the meter. And in our meter, we're creating a counter called HTTP calls. And for every HTTP calls that we get, we just increase our counter by 1. This is a very simple metric. You would probably want to do something more fancy here, like adding labels to which route you called and what was the status code, the return status code. So there is a bunch of things that you probably want to extend here. You can, of course, do it. So this is the very basic of it. But once you did that, you can, let me refresh that. So once you did that, you can go to Prometheus, put here the HTTP calls total, and you can see here all the counter of the amount of API call that we got over time. So this is how you implement metrics. Okay, if there aren't any questions in the chat, I'll keep on moving. So
I think a poll's just popped up. So sorry, Michael. I think, yeah, if we can, if you guys could just have a look at this poll and let us know what you think.
Okay, cool. So let me while you're responding, keep on showing you. So everything that we talked about so far was focused on the OpenTelemetry SDK and how it works and how to implement it within your service. So we saw the implementation, and what we did in the demo was to kind of export the data, export the spans to Jaeger, which is an open source. But there are a bit more interesting things that we can do here. So we saw the open source option, you actually have only two. You can send it to Jaeger, or you can send it to Zipkin. I would highly recommend Jaeger over Zipkin. There is a lot of vendors that you can send the data to. So you can just point your OpenTelemetry SDK to whatever destination the vendor explains you how to do, and then you do that directly to the vendor. There is a third option. As we said earlier, there is a backend component called the OpenTelemetry collector. The OpenTelemetry collector is a backend component that can ingest all types of telemetry data, all OpenTelemetry data. It can ingest it, process it, do all kind of fancy things with it, and then export it again. So why would you want to have this kind of proxy in the middle and running your own OpenTelemetry collector? And I would suggest you to do that. So one of the powers of OpenTelemetry, it allows you flexibility in terms of what you're using. So if you want to migrate from Prometheus to another database like Influx, so in your SDK, you are bound to Prometheus. But if you would send the metrics not to Prometheus, you would send it to the OpenTelemetry collector, and then the collector would send it to Prometheus. Then making a change from Prometheus to Influx is a very simple change, because you have one collector, it's the backend, right? All the SDK sends the data to it, and then you can decide that you want to ship your logs not to your metrics not to Prometheus, to Influx. So it gives you a lot of flexibility. Same if you want to experiment with a new vendor. So you can just decide that you're sending data to both vendor to POC with both of them, or you just want to switch them. So it's a simple configuration change, or maybe you want to have one vendor for logs and one vendor for traces. That's also, you can do it with the collector. So the collector just gives you one place that you can control all of your monitoring data, and something that you can define and you can play with. So I would suggest doing it. And also, there are all kinds of cool features that you can get from the collector, like converting spans to metric, for instance, and doing other things. So in general, I would very much recommend using it. All right, so now we are all very much familiar with OpenTelemetry. You can just go ahead and deploy it to production at any given day and given time. But like any technology, it has its problems and its downsides and best practices that we need to learn. So I would like just to point one significant one, and I think it's good to think on that ahead and to be aware of it. And one of the problem is that OpenTelemetry tend to be expensive. When I say expensive, well, it's an open source, it's free, right? But it's going to produce data, and you need basically to ingest this data or to send it to or to pay a vendor to do it for you, to store it and to query it. So all of this compute and data cost money. Either it's your infrastructure or for a vendor, but you need to pay it somehow. So let's dive a bit onto the problem to kind of figure out why it's expensive or what's expensive about it. And I'll break it down into the different signals, because each one of them behaves a bit differently. So the metrics is the cheapest one of all. It's the cheapest one of all for two main reasons. First of all, the data structure is very small. We're talking about numeric values over time. They are easy to transmit, they are easy to process, they are easy to storage, they're easy to query. So it's very easy to work with numeric data. And also, metrics in general are being created manually. As you saw in the demo, you need to manually create those. And if you need to do something manually, you control how much data you're going to produce. The more metrics that you create, the more expensive it gets, but it's up to you. You wrote the code. I'll just point out that there are some instrumentation in OpenTelemetry that allows you to create metrics automatically. So for instance, we saw Express, again, the RESTful framework. It can generate metrics automatically for you, and it will give you automatically things like how many API calls you got, what was the status codes, the latency. Those kind of things can happen automatically if you choose to. So this is about metrics. Then moving to logs, logs are more expensive. They are more expensive just because they are textual. They tend to be very long. We like to sense things like stack traces, which are long. So it's just a bigger portion of data. But those are entirely manual. You need to write those in order to get it. And you can control how much you're writing. And also, you can control the verbosity. Right, you can decide, I want to write this one as debug, or this one as info, warning on error, whatever. So you have a lot of play in it in deciding how much data you are going to produce. Traces, they are the most expensive one, and for two reasons. First of all, each span contains a lot of data. So you are sending what happened from this service, what is the service name, the environment that it's running in. It's a lot of data that you're sending in each span, making it just big data and mostly textual. But the biggest problem with traces is that when I showed you how easy it is to implement OpenTelemetry, you probably liked it. You probably liked the fact that I said, hey, you don't need to do anything. You don't need to inject the OpenTelemetry context yourself. It just happened out of the box. So it's a good thing that it is auto-instrumenting. However, you can't say to OpenTelemetry, hey, don't collect that. It's just once you install it, it's auto-instrumenting and things are starting to be sent out. And that's making it quite expensive. So what can we do about it? So OpenTelemetry has a concept of sampling, basically saying, I don't want to collect everything. You want to collect some of the data. So if I'll say, okay, in testing environment, collect 100% of the traces, but in production, take just 10%. That would be, it would do a lot of cost reduction. And this is what you have in the open source version of OpenTelemetry. You can just say, I want to collect 10% or whatever percentage you decide. However, there is a problem with that, because when you are saying I want to collect 10% out of all of my traffic, you're going to collect the ones that are the most common, not the ones that are more interesting for you. Again, you would use OpenTelemetry most likely for production monitoring and for responding to an incident. So then what's the most important data? The most important data is traces with errors, traces with high latency, traces that are a part of some SLO, traces that belongs to your enterprise customer that you want to give better service. So basically, there are rules that you know about your application that you want to apply, and then you want to say, those are 100% of, the rest I want to take 5% of. And this is our approach at Spectre. We provide you a rule-based sampling that you can decide which one you want to sample and which one you don't care about. And this has allowed you to better control the cost of OpenTelemetry. So before we wrap it up and we move on to questions, there are 4 things that I think if you want to go ahead tomorrow and implement OpenTelemetry, you need to be aware of. So each language has its own specific repository. So in Node.js, there is the OpenTelemetry JavaScript repository, and you probably want to go there. You would find their examples, getting started, documentation, and also a place to ask questions. So this is a good starting point. Then you have the collector. If you choose to run the collector, it has its own repository. The OpenTelemetry registry is a good place whenever you're asking yourself if OpenTelemetry supports something, I need to check that. How do I do that? So you can go to the OpenTelemetry repository. And let's say that you are using Node.js, JavaScript, and you want to see all the different instrumentations. And now you have a list of all the different instrumentation that OpenTelemetry supports, so you can know whether they are supported or not. If you're interested in GraphQL, you can click on that, and now you'll get all the information about it, how to install it, and the parameters, and whatever that you're interested in. The last resource that I would suggest you, if you want to go even with more depth to OpenTelemetry, so we created something called the OpenTelemetry Bootcamp. It's a 6 hours course, split it into 6 episodes. Each we start with the very beginning and work our way up to best practices, managing in production, all the different and customization of OpenTelemetry, everything that you need to know. It's in YouTube, so it's free. It's vendor agnostic. It's just teaching you about OpenTelemetry. So if you want to go there, feel free to go and find more data about OpenTelemetry. So thank you very much. I really hope you enjoyed it. And if you have any questions, I would love to try and help you out with them.
Thanks very much, Michael. We've got a couple of questions on the same topic in the chat around the performance overheads for kind of integrating an OTel SDK into your application. Yeah.
So basically, any monitoring solution that you implement within your application is going to have some impact. In general, all different monitoring solution has kind of the same impact. So if you're using today some vendor and you're considering to switch to OpenTelemetry, you're probably going to see the same impact. In general, you would see some increase in CPU, which usually is not that significant. You will see some memory usage because we accumulate spans, metric, and log before we ship them out. And in terms of latency, usually it's you won't see any difference or very, very insignificant difference.
Cool. Interestingly, on the Bugsnag side, we found in this case with some of our competitors who've had to retroactively make their SDKs OTel compatible, they're forced to do things like collect all the spans in a trace before they send them as one object. Whereas kind of more native OTel competitors can kind of minimize that by kind of sending spans as they come and then they're stitched together in the back end. So I guess be careful about what SDK, look at your SDKs you're implementing to check what performance overheads they could be.
Yeah.
Cool. Another question on a platform specific one on Unity. What current OTel support is there out there?
For Unity. It's a good question. I'm not exactly sure. I personally haven't had experience with implementing it. I would guess that there is. But on
the Bugsnag side, we're coming out with Unity support in a couple of weeks' time, which will be OTel compatible. Now it's not going to be full distributed tracing, but we're going to have for our performance offering, you'll be able to kind of get OTel performance metrics for your kind of Unity applications.
Cool.
Cool. I think there's another question there from Renidon. Is the rule-based sampling specific to Aspecto only?
So I know there are other vendors that have some things. In general, I think that the Spectre's one is the most advanced one. Some others, they have very simple rules that you can make, but in general, this is usually where Spectre shines.
Excellent. I can't see any more questions. That was really interesting for me as well. I learned a lot. So thanks a lot, Michael. That was really cool.
Thank you very much.
Please shoot us any questions afterwards, guys, as well. We'd be happy to answer them, and get in contact with us if you're interested in trying out any of the things that were shown today. And we'd love to kind of show you kind of the capabilities SmartBear has in this area. Thank you, everyone.
Thank you very much.